Alright, for number 7, we're going to solve another quadratic system of equations, this time by using elimination. And again, page 14 to 15, you can find more examples from your notes. With elimination, you want to add up both equations together in such a form that one of the y's cancel out. And this time, if I add them up, y plus y would be 2y, so they don't cancel out right now. So what I'm going to do is multiply the first one, multiply the entire thing by -1, and just distribute the whole thing across. So -1 times y is negative y, -1 times x squared is negative x squared, -1 times -4 is a positive 4x, and -1 times 6 is -6. And from here, I am going to add up these two equations. Okay? So, y minus y is 0. Good, the y is gone. That's what we were trying to do, is eliminate a variable. -5x squared minus x squared is -6x squared. 20 plus 4 is 24x. And then -12 minus 6 is -18. Now the first thing you might want to do with this, now we can solve this. The first thing you always want to try and do is, when you're solving a quadratic, is see if you can reduce it. In this case, they're all divisible by 6. So I'm actually going to divide out a -6. That way, again, I like my x squared positive, like I've said before. So out of every last one of these, I'm going to divide a -6. Alright, and I'll factor it out front. So 0 equals, and I can divide it out of this as well, actually. So it goes away completely. So 0 divided by -6 is 0, -6 divided by -6 is 1, 24 divided by -6 is -4x, and -18 divided by -6 is positive 3. And you could use your quadratic equation if you want, but this time I'm actually going to factor it. So 0 equals, two things to multiply to the left are x and x. Two things to multiply to the right, but add up to the middle, are -3 and -1. Those two numbers both multiply up to positive 3 and add up to -4. And when I set those equal to 0, x minus 3 equals 0, and x minus 1 equals 0, I will get the solutions x equals 3 and x equals 1. Alright, again, if you're the type that you want to use the quadratic equation for everything, we could have done the same thing. In this case, you've got your a value, b value, and c value. You simply would have just, to your heart's content, -4 would be a positive 4, plus or minus the square root of 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which again is 1. And when you reduced all of that down, you would have again gotten the exact same thing that we did over here. So like I said, it doesn't matter which way you go, you will get the same answer. And again, we're not done. These are systems, so you get 2 answers. So let's set up our points. We have 1 at 3, and one of them at 1. Take your x value, plug it into one of your equations. Does not matter which one you use. I'm going to use this one because it feels easier to me. So when I plug in 3 for x, I take 3 and plug it in for x. I get 3 times 3 is 9, minus 4 times 3, that's 12, so 9 minus 12 is -3, plus 6 is a positive 3. Is a positive 3. So there's that one. First point is 3, 3. The second one, if I take the positive 1 and I plug it right in there for x as well, 1 squared is 1. -4 minus times 1 is -4, so 1 minus 4 is -3, plus 6 is again 3. Doesn't always come out this way, but sometimes you get the same y value. So your answers are the coordinate 3, 3 and the point 1, 3.